Welcome. In this video, I'm going to talk about the observer design pattern. A common issue that arises in software design when your application is a collection of classes which you don't want to couple together tightly is that you might need to synchronize state between two or more classes. One solution to this is provided by the observer pattern. It defines a one-to-many relationship where one object notifies multiple observers about a change in its state. Respectively, these observers can update their state however they want based on the state of the subject they're watching. In this video, I've prepared a simple design for the observer pattern, and I'll show you how to implement it in C, a low-level language, so that we can understand how the logic works. All of these tips can be applied in any programming language and respectively for your software, however you want to use the observer pattern. This design pattern is widely used when you implement user interface, because there you would want some sort of layered architecture that separates data from presentation, and one data item will frequently be used by multiple presentational components. When that data item changes its state, all of the user interface components that render graphical representation of that data need to be notified for that state change and act respectively to update their user interface and how they render the data. This design is comprised of two classes. The first one we'll look at is the subject. The subject is the actual object that will notify observers about state changes in itself. When observers are notified, an update function is called in the observer so that they can modify their state respectively, however they wish, because they get the newly updated state as an argument. The subject class in this design has its state as an std string variable called mState. The m prefix is frequently used in C to denote member properties that are private. In this case, the state is a string, but a state in real application would usually be an object on its own with multiple properties or a different data type. But the actual type of state is not important. Here we care about the mechanism by which the subject will notify observers about state changes and how we synchronize these states between different objects. Besides the state property, subject also has a vector of observer pointers called mObservers. It needs that vector because when notify is called to notify the observers that a state change happened, it needs to know which are its observers. And it can iterate through this data structure. In this case, I've chosen a vector, but it can also be a list. It can iterate through it and call the update function on each observer. Quite elegant. We also have a setState method, which updates the state of the subject. This can be a different state update mechanism. This is the simplest case for state updates. And we also have an attach and detach methods that accept an observer pointer as their argument in order to add or remove observers from the observer's vector. The other class in this design is the observer class that is related to subject by composition. Of course, observers are contained in subject in the mObservers vector. The observer class is a little bit simpler. It has a state on its own. Usually the observer and the subject will always have a state in any design because the whole point of the observer pattern is to synchronize states. Although keep in mind that the state of the observer and the state of the subject do not need to be the same. In fact, they almost certainly wouldn't be the same. The state differences can be whatever you wish. The observer will get its update method right here and receive the updated state of the subject when that happens. And the update function on the observer can change the state of the actual observer however it wishes. It gets the information for the updated state in the subject, but it doesn't need to replicate that state exactly, of course. And we also have a method implemented called getState. This is primarily for purposes of this demo in order to access the state and demonstrate how the observer state changes. Usually, of course, you would have some way you would need that state in the observer and use it to either render something if this is a graphical user interface component, or use it however you wish inside the component to do computation, to do whatever logic you wish. The main point here is not how we use the state, but rather how we synchronize the state between the observer and subject. I know I repeated that a lot of times, but that is the main point of this design pattern. So I've implemented this. This is probably one of the simplest cases of subject and observer, and I think that's good in order to understand the essence of the design pattern. I've implemented it in C, and I have it right here. You will have access to this in a GitHub repository that is linked in the description. It also have instructions on how you can build it and run it on your system. It has a make file here to facilitate the compilation process, but the main source code is in the src folder as is standard. Here we have basically the most minimal setup. We have the header and CPP files for subject, observer, and we have a main file that is only used for a demo purposes. It instantiates an observer subject and outputs to the console their state. In fact, let's start from the main function, as that is usually a good idea. So the main function imports the observer and subject classes. We'll look at their implementation later, but their implementation closely follows this UML class diagram, so you already have an idea about their methods. They're quite straightforward. So we make two observer instances. Here I create a new observer instance as a shared pointer, but that's not essential. The important part is that we have two instances of observer called observer instance and observer instance 2. Then I create a subject called subject instance. And I use the attach method on the subject to add the two observers as observers to that subject. Quite straightforward. Then I update the state of the subject. The state is a string, so I update it to this value right here. And I output to the console that the subject state updated at this point, so that we can see in the application that this stage happened. And then, as I say in the comments, I print the state of the observers, because when this state change happened in the subjects, in the back, the notify function should have been called because setState calls that notify function explicitly, and the observer state should have changed automatically. So we output it here. In this specific case, I've made the observer state synchronized with the subject state. So we expect the state of the two observers to be that string. If I compile my application now using make and run it, it's in this program after compilation, we see exactly the expected behavior of this observer implementation. The subject state updated at this point, and the state of my two observers immediately after that is updated to the string to which I set the state of the subject. So my observers correctly got notified and updated their state. Let's look at the internals of these two classes, as this is more interesting. I will start with the subject and its header file more specifically. This follows very closely the UML class diagram we have here. The only difference in the UML class diagram, I denoted pointers with classic C++ pointers. Here I used smart pointers for more modern C++, more specifically shared pointers. So the attach and detach functions accept a shared pointer to observer, but it's still a pointer in its essence. setState accepts a constant string, and the notify function is just a void function. We have the two member properties, the vector of observer pointers, observers, and the string state variable. Let's look at the implementation of each of these methods. Here we have the attach, which, as this observers is a vector, is very simple. Just push back the new pointer to the observer. Detach is also simple. I use the std erase function to remove a member from to remove this item from the collection. This std erase function works on all container types in the standard library. And in fact, because it's a part of C++20, my VS Code is marking it as incorrect. as it doesn't realize it's actually a valid function. We also have the setState implementation here. It's quite straightforward. We receive the new state as an argument and we just set it. Then we call notify in the setState method. Now, this is one way to implement the subject. In some implementations, notify might not be called by the state changing function explicitly. And as notify is public, the developer could call it on his own. I don't like this particularly. It has its advantages. If we don't call notify here, we can call setState multiple times to do a bulk update. If that is necessary, change the state multiple times and call notify only once. But this makes calling notify the responsibility of the developer, and a lot of mistakes can happen this way. If notify is called by setState inside the setState function, if you do multiple state updates and you don't need to notify the observers about them, that would mean you have just unnecessary notify calls, which could be expensive sometimes indeed, but there's much smaller chance for errors this way. We also have, lastly, the notify function, which is very straightforward. I've implemented it with the simplest way I could think of. We iterate through the observer's vector, take each observer, and we call the update method of each observer. Of course, it's guaranteed that the update method is implemented in the observer class. That's what this subject depends on. In fact, let's look at the observer now. I'll start with the header file again, which again follows closely this UML diagram. We have the state private property, which is a string. Again, in a real app, it most likely wouldn't be a string. And we have the getState method that will simply return state as it's a private variable. And we have update. The update method is implemented as you wish. In your specific business use case, it might do different things depending. The string that is received as an argument is received from the subject with its state, its current newly updated state, and you modify the state of your observer as you wish, depending on the input you receive from the subject. Let's look at the observer implementation. Quite simple, two methods. GetState just returns state, member state variable, and update in this case is very straightforward because I just mirror the state of the subject. So mState here is equal to new state, which is the received argument from the subject. As I mentioned, in many cases, you might need to modify the state here and not just replicate it. And this is how this works internally. Very simple. This is one of the simplest implementations of the observer pattern, but I believe that's the best way to learn it, to understand its essence. Then you can complicate it however you wish. There are many opportunities to complicate the observer pattern to make it more optimized and even more abstract than it already is. Again, you can download this demo app and play with it. Take a look at how it works. The repository will be linked in the video description. With this, I'll wrap today's video. If you enjoy the content, don't forget to subscribe to get notified when I release another video. Take care.